Question number 4 on page 178 from section 4.3's homework reads, a string is tied to a 4.4 kilogram block and a 120 gram hanging bucket. Students add 20 grams of washers one at a time to the bucket. The students are unaware that the coefficient of static friction for the block on the table is 0.42. In part A, they ask us to determine the maximum force of static friction for the block. So we know that friction can be found in the equation mu s equals the force of static friction over the normal force. If we rearrange this, the force of static friction is equal to the coefficient times the normal force. Since this object is resting on a level surface, we know that the normal force can be replaced with the force of gravity, mg. So we can determine the maximum force of static friction by plugging in the coefficient of 0.42 times a mass of 4.4 kilograms and multiply this by 9.8 newtons per kilogram. If you punch this into your calculator to two significant digits, you get a force of static friction of 18 newtons. Now, in part B, they ask how many washers can the students add to the bucket without moving the block? So if we take a look at the block and draw a free body diagram, we know that tension, when you add the washers to the bucket, will be attempting to pull the block forward, while static friction will be keeping the block from moving. So it's important to note that in this situation, the object is not moving. So the net force on the object must be 0. In order for that to be true, the force of tension has to be equal to the force of static friction. That we've identified the force of static friction as 18 newtons. Now let's take a look at the bucket. The bucket will be acted upon by a downward force of gravity. Well, it will be supported by an upward force of tension. If the system is not moving, as we've indicated, then in this situation, the tension has to be equal to the force of gravity. And we've determined in this statement here that tension is equal to the force of static friction. So we can then say that the force of static friction is equivalent to the force of gravity. So the 18 newtons of static friction is going to be equal to the total mass of the bucket and its washers times little g, the gravitational field intensity. So to determine the total mass of the buckets and its washers, it'll be equal to 18 newtons divided by 9.8 newtons per kilogram. If you punch this into your calculator, you end up with a value of 1.85 kilograms. In order to determine the number of washers, you need to subtract the mass of the bucket from the total mass in order to determine the mass of the washers. So if our total mass is 1.85 kilograms and the mass of our bucket is 0.120 kilograms or 120 grams, then we can say the mass of the washers is 1.73 kilograms. So that's a total mass of washers. If we want to determine the number of washers, it's equal to the total mass of washers divided by the mass of one washer, which is 0.020 kilograms, or 20 grams. So 1.73 kilograms divided by 0.020 kilograms, you end up with 86.5 washers. So 86 washers would result in the block standing still, but 87 washers would cause this system to start accelerating, the block to the right and the bucket down. So 87 washers would be required to start motion. In Part C of this question, they ask, will this investigation yield an accurate result if they use it to find the coefficient of static friction, and explain your reasoning? Well, this investigation may not yield accurate results if the students use it to find the coefficient of static friction. The number of washers added is a discrete quantity, so the total mass found could only differ by a quantity of 0.02 kilograms. This difference will affect the accuracy of the maximum force of static friction used to find the coefficient. You would need smaller incremental masses in order to determine an accurate value of the coefficient of static friction. In Part D of this investigation, they tell you that the coefficient of kinetic friction is 0.34, and they want you to calculate the acceleration of the block when the final washer is placed in the bucket. So let's be clear. If there are 87 washers, each with a mass of 0.020 kilograms, this gives us a total mass of washers of 1.74 kilograms, plus we know that the mass of the bucket is equal to 0.120 kilograms. So the total mass of this hanging bucket and washers is 1.86 kilograms. This is the mass of the bucket plus washers. So draw a free body diagram of mass number 1. We know that tension is pulling it forward and the force of kinetic friction will be opposing it in the backward direction. So we'll list the forces acting on this object, and we say that the net force is equal to tension minus force of kinetic friction. For the hanging object, mass 2, we know gravity is pulling it down and tension is moving it up. So if we write our statement, we say net force is equal to gravity minus tension. So let's proceed. Replace this with M1A equals tension minus force of kinetic friction. And this one is M2A is equal to M2G minus tension. Solve these both for tension, as we've done in all previous examples. And we have tension is equal to M1A plus force of kinetic friction. And we have here tension is equal to M2G minus M2A. Since tension is equal to M1A plus kinetic friction and tension is equal to M2G minus M2A, we can equate these two statements and say that M1A plus Fk is equal to M2G minus M2A. In order to solve for the acceleration of the system, we have to group like terms. So we're going to bring all values with a to one side and move anything that is not an a from that side. So we end up with m1a plus m2a equals m2g minus fk. Next step is to factor out the a from the left-hand side, and we have a is equal to m1 plus m2, m2g minus fk. Divide both sides by m1 plus m2, and we are left with acceleration is equal to m2g minus fk divided by m1 plus m2. So before we go ahead and sub and solve, what we need to do is find the value of kinetic friction. So they gave us the coefficient of kinetic friction. And the equation for kinetic friction is the coefficient times the normal force. And in place of the normal force, we write mg. In this case, it's m1g. So we have 0.34, the coefficient of kinetic friction, times a mass of 4.4 kilograms, times 9.8 newtons per kilogram. If you punch this in your calculator, you get a force of kinetic friction of 14.66 newtons, which to two significant digits we'll say is 15 newtons. So now let's go and plug that in here. So in determining the acceleration, we say the mass of the bucket and the washers is 1.86 kilograms times 9.8 newtons per kilogram minus 15 newtons divided by m1 is 4.4 kilograms and m2 is 1.86 kilograms. Carefully we punch this into our calculators and we end up with an acceleration of 0.57 meters per second squared. Remember, if we're talking about the block, this is to the right, and if we are talking about the bucket, this is down.